clicking the button. Great, we're live. Great, guys, welcome. So for the introduction, this is a webinar with a layout parser core team, Shannon and Ben. I'll let you guys introduce yourself, and we are focusing here today on building the customized layout parsing models for scientific paper PDFs. So guys, can you maybe introduce yourself, and I'll have some follow-up questions. I have curious just how you got to the idea of building that software.
Shannon, you want to go first?
Thank you, Ben. Yeah, thank you, Michael, for the introduction. And I'm Shannon, and currently I'm an applied research scientist at an Institute for AI. And basically, I work at the Semantic Scholars team, which is like a website for organizing this like scientific literature graph. Try to build like easy interface for you to search and read papers. Perhaps Ben can introduce yourself.
Definitely. Thank you, Shannon. And thank you, Michael, for the introduction as well. So hi, everyone. I'm Ben. I'm a fourth-year PhD candidate in computer science and engineering at the University of Washington. And I first met Shannon, I guess, about a year ago. My research interests generally overlap pretty heavily, but at the intersection of machine learning and cultural heritage. So a lot of what I do is work with, say, digitized newspapers or historic documents. And so really the question of doing proper layout analysis really emerges as one of the base questions there. And so I've been fortunate enough to be able to participate in some layout parser project more generally and collaborate with Shannon on how we can use sort of cutting edge document layout analysis to really improve access to cultural heritage.
Cool. And just for the history, I guess, how it all started, the library.
Yeah, perhaps I can share a bit about this history. So I originally also worked a bunch of like digitization of like historic documents when I was working with Professor Melissa Dell. And at that time, the key question is just we are showing here, which is like the documents will be having tons of complicated layouts, and existing OCR software just cannot resolve this issue. So we have like built upon like another layer of parsing function based on layouts. And during that stage, so we iterate and design several like an original version of this like layout parser tool, and then finally we gather a bunch of ideas together, and then Ben and many other courses we work together to build upon this like the current version of the layout parser tool.
Interesting. And how old is the project right now?
Yeah, it's amazing. It's almost 3 years, I think. Right, we started something in the mid 2019.
And I'll also add that Shannon is modest, but Shannon is the real project lead behind layout parser and everything. I'm just fortunate to be a small part of it, but this is all the intellectual work of Shannon and implementation work as well. So happy to be here and also excited for the demo too.
Interesting, Ben. And I just a follow-up question on that, like, how did you end up picking your PhD thesis?
Yeah, no, that's a great question. So my sort of the central area that I sort of do CS research in is sort of in human AI interaction with a lot of sort of emphasis on exploratory search systems. So getting in this space was largely through a project with the Library of Congress called Newspaper Navigator, where I've been working effectively to sort of reimagine how people search over the visual content in historic newspaper pages. And so it's been I've really enjoyed the space just because it has access to a lot of really, interesting questions from human AI interaction or interactive machine learning, but also, has a lot of opportunities there to collaborate, say, with, humanists or social scientists as well on how they use the kinds of downstream search systems that are built. So, and also, of course, being able to collaborate with Shannon and others on questions like document layout analysis too.
Interesting. Is this like the same where they show in the movies where like those old computers with newspapers that you put under the light and you kind of have those archives?
Exactly. Yep. So starting with raw microfilm, then those get digitized, and those are typically the newspapers that people start with, and these kinds of large newspaper databases like Chronicling America. But yep, definitely that visual is it.
Cool. Okay, we should have used that for the webinar.
Exactly.
Right. Cool. I guess let's get started. Shannon, I'll let you go to the next slides.
Perfect. So Yeah, so the general structure here is I'll give about a 5-minute introduction, then I'll turn it over to Shannon, who will be doing the bulk of the demo here, and we'll give a little bit more detail, but do want to leave some time for question and answering and questions here toward the end, so at least 10 minutes or so. But yeah, with that, I can give some high-level motivation behind this work. So generally speaking, this question of how you start with a sort of raw document, whether we're talking about a digitized document or a born digital one, such as the scientific paper on the left, there's this really sort of pervasive and ubiquitous question of how we convert that kind of document on the left into some sort of semantically, usable content. For example, on the right, where we might have metadata fields, title, authors, abstract, in the case of a scientific paper. In the case of a newspaper, we might want to have the headlines or general understandings of articles being disambiguated. In the case of business analytics and business documents, there's tons of form structures that being able to extract relevant information really becomes essential in operations as well. So the next slide. Perfect. And so I think the real question, or the central dilemma here for those who have ever really done any research or tried to use these kinds of tools in this space, is that if you start from raw text, the output is never great, and it becomes really difficult to learn this just from raw textual representations. And of course, this makes sense. If we go to the next slide, we actually, as human beings, really rely on the kind of layout to get a sense of where a title appears on the page or where the abstract is. These things are communicated not just through text, but also through sort of visual flagging as well. And this is pretty ubiquitous too, right? So in a scientific paper, we have some sort of visual grammar for how to parse it. Same deal if we're looking at really any kind of document or book as well. And so this is where LayoutParser comes in. And so LayoutParser is a pip installable library for document layout detection. And it, of course, uses deep learning, as we'll get into. But the general idea is we can start with the document on the left and then end up with the document layout structure on the right, where we really do have something that's fully parsed and semantically extracted that we can then pass to all sorts of downstream tasks. And so here, for the case of LayoutParser, we're using things like the layout data APIs to be able to make these kinds of queries, pull down models, et cetera. And so in the context of this presentation today, we're going to be looking at really this question of I'll mention as well that LayoutParser lets us to generalize to different data types quite quickly. So using a layout model that we might pull down from the model zoo in LayoutParser, we can annotate some data and then fine tune it on a model to basically have it learn how to predict with high precision on a new data set as well, or a new data type. And so generally speaking here in the context of LayoutParser, and this I should say more generally in the demo, if we go to the next slide, the idea is we're going to start with some new document data. We can use Label Studio to go ahead and annotate some data to produce like a training and evaluation data set. Then we can shift over to using LayoutParser to do some model training or fine tuning. And then we can lastly apply those new models to whatever corpus we're interested in. And so here's where we see this intersection of LayoutParser and Label Studio, how we can really do this end to end in a way from just starting from raw documents and pre-trained models to something that's fully fine-tuned and extensible or scalable to being released on an entirely new corpus. So with that, let me go ahead and turn it over to Shannon here.
Sure, I have a question.
Oh, yes.
Before we jump into the demo, what people were using before the layout parser, I guess?
That's
Have
a great
you used
question.
something yourself before that?
I would say that's part of the reason why we try to build this LayoutParser tool, and we hope this can be like a community. This tool can be shared with the community, because I worked on this space before the emergence of LayoutParser, and then I think the common or maybe what happened most is that you have some specific problem, you go for a search on GitHub or maybe on Google, and then you will find someone who might be kindly build something there, and then you can directly use it, right? But the issue is that if you want to scale up your infrastructure to be applied to multiple types of documents, then the resources for this different types of document might be different. And it takes just like an extremely laborious work to learn for this different infrastructure, as well as their different ways for doing stuff. And then this goes to the idea which we should try to find some mechanism that can unionize all this different infrastructure and framework that other people have built, and that's reached to this like design of the LayoutParser tool.
And I would say that, on top of that, one of the things that I find layout parser to be particularly useful or valuable with is not only does it, do this kind of last step model fine tuning, but as a sort of general library, it supports the infrastructure from training or from labeling all the way downstream. And so I think even in some of these, solutions that I had seen online or whatever, these are oftentimes pulling down pre-trained models, but there's really no infrastructure to how one even goes about producing a training data set for something like this too. And so I think this kind of full ecosystem or pipeline for doing this is particularly valuable, at least, for me as someone who's been on the other side of this, trying to use these kinds of tools as well.
Right, and would it be correct to say that before the layout parser, you would just use some software or build some software that would be very specific to your use case, but now you have a framework that can easily generalize across different types of layouts?
Yeah,
exactly.
I would say that exactly. Yeah.
Interesting. And basically, you do the labeling to enable that generalization over your specific type of the layout that you have. Yeah. Okay. Yeah, I think that makes sense. Any questions, I guess, from people on the stream right now before we go into the demo? I think we can. Okay, I think we can jump into that.
Yeah. Cool. All right. Cool. So let me switch the tab for the demo here. And basically, I try to organize everything I'm going to demo in this like a Jupyter notebook. And basically, the goal here is trying to, just like I mentioned, right, customizing the parser models with the help of Label Studio and annotation, using this like scientific document parsing as like specific example here. Okay, so basically, we'll have like 4 steps in this process. The first thing is trying to define, I would say clearly define the problem and the target. And then we want to create the training data set for this based on this target, as well as train the layout models. And finally, we can use this newly trained models for our specific parsing purposes. And then let's jump to the first part, which is define the problem. So in scientific document understanding, one important goal is trying to understanding this like a bibliography items, or maybe just like each individual references listed at the end of each paper, right? So basically, I show on the left, which is like an original screenshot of like one paper, which you typically see nowadays. And on the right-hand side is what we want to have for this paper, which is we have this like we detect one block for each of the bibliography item, and which we can use them to parse this page. It's like a 2-column layout format into a structured CSV or even JSON, which we can analyze in the next steps. And this tutorial will show how we can get from this source output, from this source page into this like intermediate layout representation, as well as this output data structure for this like bibliography text. Okay. And before we jump into building something new, perhaps one thing we should do is just try with some existing models. So I'll just restart this kernel to make sure I just run this thing, all this stuff live. So basically what we have is that we can just like download some random test PDF. And then we can find a model from this like a LayoutParser open platform, which consists of a bunch of models and even pipelines shared by the community for different type of data sets. So we can choose this like a specific like a scientific documents, and then PubNet is just one such data set for like parsing the general structure of the scientific document. So we probably want to choose this like PubNet models. So we can choose either of these models. Perhaps I'll just choose this one because it's just like the fastest one. I don't want to wait really long for getting the results. So we can just paste the code here, but anyway, it's more or less the same. So we can just use this one here. Okay. Yeah. And then the model is being loaded, and then we can apply this to detect the layout of specific page. And then we're running this like layout detection for the specific page, and then we can get the output visualize its layout annotation results for the specific page. As you can see, this like each yellow rectangular box correspond to like the detected layout regions. As you can see, it's just not perfect, right? It will mingle some of regions together and then generate some boxes that doesn't make sense at all. And that's probably the reason why we want to build such a new model for this. And also we want to check whether there are some existing data sets, right? Unfortunately, let's say we don't have that now, okay? And then it goes to the next step, which we have to create such a training and evaluation data set for this task. And then the first step is we have to obtain some source data set. I mean, this kind of depends on your target. I mean, for most of the document parsing researchers or practitioners, they typically have the data from their the providers. I mean, for this task, or you can just download a bunch of papers from the familiar providers as well. And then the next step is to set up the Label Studio interface. So it contains like three tiny steps, I would say. So one is, first thing is you have to install a Label Studio software, locally, and have the server start running. So basically, the Label Studio GitHub repo is the great resources you can turn to, and basically it provides very detailed explanation for how to install the software. And then I choose this version specifically for the local development, and I run this sort of code to start the running server. And then we have one version of the running server here. So basically we jump to here, and then this is a live server now. So the next step is we want to create like an annotation project for our data, right? So basically what we want to do here is just create a button and then say bib item annotation, right? So we save this project, and then we can import some data or maybe some images, which I have viewed, already downloaded, and then stored here. So we can just import and send it to the system. And then, but before you jump to the annotations there, we want to set up label interface, which is another feature I kind of like for the Label Studio, which allows you to customize the label interface. So there are a bunch of templates you can configure the labeling system. And for us, we have this some snippet for configuring this label interface such that we can have the annotation on the right-hand side of the images. And then here we click, click the save button here. And all right, so we configured the labeling system, and then you can start annotations here. So basically you just click this specific label here, bib item, and then you just draw a rectangle for each bib item, just like we show as the first example, right? You can do this repetitively for another example here. I mean, okay, just one last example here. Okay, and then after drawing this rectangle, so you can just click the submit button to finish annotation for one example. But I won't show this annotation for the whole data set. I mean, we pre-labeled a data set there, and you can see we annotated a bunch of samples for these different pages. And okay, then the next step is, okay, after finishing annotating a data set, right? You want to export these files to a local environment. In this case, we choose this COCO format because this is a format which optimized for training such models. And then you can click the download button to download it locally. Yeah. Okay, so we have this a folder there, and actually we have already copied this folder into this folder here, which is this is because called it download annotations, which consists of one folder and one file. Which one is result, which is a JSON storing the annotations we just labeled for each image, right? Basically, it stores a bounding box on the page. And then there's an image folder here, which contains a bunch of image we just uploaded to the system, right? So, okay, so now we get the annotations ready for this data set. And then we can go to the next step, which we can check the annotated data, right? So just want to make sure we get everything right and we get the formats right. So we can run some code here, which we can easily find from the LayoutParser tutorial as well. And then we can just download this annotation, and then we can randomly display some annotation as well. So for example, for this page, yeah, we got annotation for this page, and similarly for the other one. Okay, so so far so good. Then there are some optional stuff which won't be covered, but I think that be very important to mention, which is for most of the annotation tasks, it's very important for us to define a very clear and crisp annotation schema, such that when you distribute the annotation task to multiple people, they can execute it accurately. But since given the time constraint, we won't cover it in today's webinar. Okay, so we got the data, and then the next steps, we want to start training the layout models. To do this, we provide, LayoutParser provides a script called layout model training repo for given like a new data set. We want to produce a kind of like a new layout model that can work okay for this new data set. I mean, depending on the size and difficulty of the data set, right? It can perform, okay or even perfect, right? So, and in order to use this in conjunction with the data set we just created, so basically we want to clone this repo into like a local folder. We just run this command, and then you can see we have already done this. We have already saved the folder here, right? And then we can copy our data into this like a data folder, which we also have done this. And the next step, I would say pretty important, is that we want to create like a trend test split data set for this. So now we only have this like a one file for all the annotations, right? But in order to train the model, you want to split them into like a training and evaluation data sets there. And basically what I can do here is we also provide this like utility script for splitting this data set into the training and evaluation data set, and then do it here. So basically we can, so we are in this like a layout model training folder, right? We can go to this like a utility folder, which we will see this like a total split script, and then we paste in this command here, and then move some spaces at the end. So okay, so we hit and run this command here.
I have a small question. How long it takes for layout parser model to train?
Oh yeah, this is more or less depend on the size of data sets. But if you have like a GPU machine and you have something like 100 examples, you can get a trend within just like a 1 and even half an hour. Yeah. Okay. And then, okay, as you can see, we run this command, and then this will be break down into these two files, which is like a test and train file, right? And then you can see we have like a total of 22, image examples in total. And we split them. We set 18 as like a training samples and 4 as this like testing samples here. Okay. So all right. So the next step is we can go. We just need to train the models actually using this new data we created, right? So we can go to this model folder, and then there's like a scripts folder which contains also scripts for training the models. So I want to show you this like a train prima script first, which is like the first, the exemplar script we provided by default in the library.
And Jen, actually, real quick, looks like we have a question in the chat and in the QA as well.
Okay, cool. How about I finish showing this, and then we can jump to the QAs. Yeah, cool. So basically, this is where in this like a train prima script, which we show this like data conversion as well as it's like actual training command. Basically, just need to take in a bunch of data set as well. There's a name as well as the paths to the files, and then specify like a configuration file as well as like the output directory, and then you can start training the model. So basically, we can modify this into our train bib script, which is like we have this like a bib item data set, which we just labeled, right? And we have these files. And then we can specify a configuration file. In this case, we just like use this like a prima dataset file, but we can also customize it if we have more time. And then after we got this like training file here, the next command we want to do is just like a bash train bib.sh, right? I mean, I'm on my local CPU machine, so this is definitely not a friendly script to run on your CPU machine, and I'm also doing this like a web streaming, screen sharing. So I just stop it here just to avoid any kind of like a bad issues happen to my computer. But assuming you can get this running for a while, you'll get like a new set of models just like we have here. So we have just like a big models here already saved, sorry, in this folder. And then you got this like a model final, as well as like the configuration for this models, which can be used for it's like a layout parser models. Yeah. So okay, so we have a question, and shall we go to these questions?
Yeah, I think the question is around what size of the GPU would you recommend for training? Would something like that available through Collab Pro be good enough?
Okay, so typically I would say you need something better than K80, which at least something like a 12 gigabytes of GPU RAM, or maybe at least K80, I would say that. If you and now I think if you use something like AWS P2.X large machines, you should get this like a stuff ready. Yeah. And I also, yeah.
Sorry, another question that I have from my side. Have you tried any type of active learning approaches with layout parser?
Yeah, we have done that before, and actually we have like a paper for specifically optimizing active learning for layout object annotations.
Maybe you can touch on that briefly, just for the audience who doesn't know what active learning means. Like, what is the value that it provides, I guess?
Yeah, happy to share with that. So basically, active learning is the goal for active learning is that we humans tend to be not working that much. We tend to be a little bit lazy, not trying to label all the samples. So the goal is that given the same labeling budget, active learning is trying to find the best way to label the data set such that it can optimize the model performance. It sounds like a bit weird, but the reasoning behind this is that in active learning, researchers believe that not all samples are equally hard to learn. So there might be some, very confusing or maybe very challenging examples that the model should be seeing. It'd be great if the model can see them first. And that's where active learning comes to play. So basically, this kind of study tries to build a system and methods, try to evaluate the difficulty for learning for the samples, such that we can have better ways to schedule the labeling process. We can label this like hard samples first, and then such that if the model sees this hard samples first, then ideally it can perform better.
Yeah, it's also kind of focusing on what's the most beneficial items for model to learn from, kind of the ones that are most information rich for the model. Yeah, it's cool that you have implemented that with layout parser, because I think it's in case you have a really large archives, you would not be able to label all of that by hand. I think it's important to kind of focus on the items that are important to the model. We have another question. H&M, do you suggest fully to replace PAWL?
Yeah, I know this question. Yeah,
with Label Studio.
Yeah, that's like a great question. So let me first explain here. So Pause tool is like another tool we built earlier last year for annotating PDF documents. The benefit for that tool is that it will automatically identify the PDF tokens stored inside this like PDF document, such that it can automatically rectify the drawn binding boxes. So let me show specifically in this example here, which is, so we can go to this one, right? And for example, here you got this like a page here, and if you draw a binding box here, it can. If you randomly draw a binding box like this, right? Definitely there's just no text in the background, right? So Pause can do something, automatically train this box to snap to the token region there. which is basically very beneficial for this like specific PDF document annotation task. As long as you have this like a digital bone PDFs with this like a nice token representations. But we also find some issues with parse, which is if the PDF is not perfect, especially if you have PDF from something like around 2000, even before that, or if you just have a scanned document, this argument is not perfect. So it will just like give us some okay boxes, or sometimes can be like a very annoying to fix them. So that's where I think it's more or less like depending on your task, right? If you have like a full confidence of your PDF representation, then I think parse is the most effort-saving path. But if more generally, if you have this like a general scenarios documents, I would say LayoutParser Studio could also be like good option for these scenarios.
Cool. Yeah, I think Matt is saying that it's a scanned facts PDF file. So yeah, I think for the scanned ones, it's basically an image embedded into the PDF file. Yeah.
Yeah, I mean for scanned ones, I would say it still depends on more or less on the complexity of the documents, right? If your document is like a more or less like high quality one, which also may be relatively simpler structures, then you can expect the OCR quality to be relatively better, right? Such that you can get nice token representation, then you can use parse. But otherwise, if it's just like a low quality scans, then it's more or less maybe just using something rudimentary or maybe flexible like Visual Studio as well. It could be like a better.
Yeah, Matt is saying it's not high quality.
All right. I mean, yeah, I totally emphasize your experience with like a low quality scans, because that's definitely very hard to deal with. Yeah.
Yeah. All right, I think let's continue, and then we can jump back into the Q&A.
Okay, cool. Okay, so we got, I mean, we chat a bit, and then let's assume, we are waiting for training for the last 5 minutes, right? And then we just grab another coffee, and then we go back, we got the models ready, right? So here we can just load the models with this train. I mean, to make it more, realistic, I would just type this like a full paths for this. So we have this like a layout model training, right? And then we have this like the outputs. We have this like a big data set, right? We got this, and then we got this like a first RCN models train, and then we have this like configuration file, right? And similarly, we can copy this path as well for this one. All right. Okay, so we can load these models here. And by the way, I set like an additional threshold for the model confidence output. Basically, it says that for all the predictions that has like a lower than 0.8 confidence, it will be dropped or will be removed. Okay, so we just run this, and it will initialize the model we just trained. And okay, we will run the detection for the same image we just tried before. So let me just put it up and just remind you, it's this page, and then the prediction for this one is not great, right? Just like the one here. So we will run again using this new model, which is initialized, and it takes several minutes, and then we can just draw the layout region on this page. Okay. It's kind of slow because probably because I'm screen sharing, but yeah, hey, you got it. So this is the model prediction directly out of the model, which can be seen as like relatively higher qualities, right? And we can just try another PDF, and we can just randomly grab another PDF, and as well, and to make sure we are testing something purely new, and it's still downloading, but we can go here, which it takes a while. That's because I'm screen sharing, so it's kind of slow now. Yeah. Okay, so it's being downloaded, and then we can run the same layout detection model on this page, and yeah. Okay, so generally speaking, that's like how you label the data, and then you train the model, and then you use it for your you get the layout using the new model, right? And oh my God, it's being extremely slow now. So it takes such long to get outputs. But I believe the next part of code could take shorter time. And then, I mean, well, we are waiting for the output. Okay, it's here. So as you can see, that's the model output here. I mean, it's still not 100% perfect, right? There's like a tiny missing of these regions here. But I mean, that's always like a spaces for improvements if you can get more data or if you can train better versions of the models, right? And then let's jump to the specific question we are thinking about, which is like parsing the structured data from these documents, right? So basically now we know this model can detect this like a big items, right? And then we are thinking, how can we get the text out of this like a regions, right? I mean, now we just have this images and this like a box, right? We have to get the text out of it. So basically we know this like 8, 9, 10, these 3 pages are reference sections. So we can iterate through these pages and we can detect the layout first. And while we're waiting, and let me explain what's this part of code doing there, right? So basically for each page, we'll detect a collection of boxes, each one of them denoting a bib item region, like the one shown here, right? So for example, this is like a 2-item list here, right? So, and we want to iterate through this list as well, such that we can get the PDF tokens inside, or maybe PDF words inside this region, which is what this code is doing here. And we can also run this as well. Okay, so, and then we can show what's going on, what's actually for the bib tokens, right? I mean, we have this like a break command, so we just run it for once and then we can show it here. So we got it here, which is like basically a collection of PDF tokens here inside this region. And then we can overlay this. I mean, we can overlay this like PDF token region with this, the detected bib item region as well. So as you can see here, so basically the red box, I probably should choose 2 different colors, but the red bigger box is this like bib item region. And then this like individual, colored boxes are the individual PDF tokens. And then we have this like an easy command to get the text directly from this region, from all these like bib tokens inside this region. And this is actually our goal for extraction, right? Saying that we want to get this like a, bibliography entries from this document. And this is the actual bibliography entry, right? So if we combine together, we can iterate through all the pages. We can get a bib item for each page, right? And then we can get the text for each bib item, right? So we can get the text and then we can combine them into like a list. Perhaps this might take some time to run given the situation on my computer, and I can try to answer more questions in the chat. Well, we're waiting for the running results.
Okay, I have a question, and then I guess I will go into the Q&A. For the example that I think Matt was bringing, would that mean that after you train your layout parser model and you get the layouts, you would, because it's not a PDF but it's a scanned image, it would go into the OCR model to extract the text, and that's how you would. So there would need to be an extra step there to do that. Interesting. I wonder, Ben, if you have done something like that with any of the documents that you're working with.
Yeah, no, that's a great question. So to be completely like to give context for the most recent stuff I did with Newspaper Navigator. So I actually relied on sort of a customized annotation system that the Library of Congress had used for like a crowdsourcing initiative that they had launched. So I actually didn't really do too much sort of customization when it came to the annotation stage, if that makes sense. And the extraction stuff, basically, they would annotate, and then we'd take OCR falling within the bounding box, sort of generally speaking. And then we'd use that sort of as like a textual caption kind of deal. But that's sort of the extent to which we've used it. So I would say that partially, and I did some additional annotations, But I mean, I think there's always an interesting question about how, we can utilize the kind of customization here to sort of, if we were starting from scratch, how we would reimagine doing that.
Yeah, it's just very interesting if you're thinking about the type of documents that you're dealing with, and like the OCR systems of today. That's usually that probably never saw those types of documents. I'm just wondering like how well they would perform on those like old newspapers and things like that.
Yeah, no, that's a good question. Sorry. Yeah. So yeah, I think in regard to that portion of the question, I would say that the performance tends to be highly varying. I mean, the other point that I should probably make here is when I use the kind of OCR, it's literally the localized characters, not really worrying about how it captures sort of semantic blocks or things like that. There's definitely gains to be had from better layout detection, no question. And in a sense, we're sort of doing that post hoc on top of what's already there. And and Shannon's experienced this too. I think there's just always this sort of bottleneck or this ceiling on OCR quality as a function of the sort of digitization quality too, that just always introduces noise. So, if you're looking at millions of newspaper pages, some of them inevitably are just difficult to even read by eye. And then when you introduce the whole level of OCR on top of that,
right,
basically renders it to be a complete, very, very much a nightmare. But
right.
Yeah.
Yeah, cool. I mean, yeah. I would also add to Ben's point, which is in my previous life, I also worked on this like newspaper stuff, and I think one thing we come to conclusion is that if you send like a whole newspaper page for OCR, it will be much worse compared to if you send like a small segment of regions, something like this, which there's like a very simple layout structures there into the models. That would give us segmenting this small object with like simple structure can give you like a huge bonus for this performance if you are using just the same tool there. And that's also part of the reason why we think this like validation is like such like an infrastructure level of doing stuff there to improve the overall performance of both the information extraction as well as like OCR process.
Right. Okay, so the question from Thomas is, what is your experience with synthetic training data?
To be completely frank for this question, I have never tried using a lot of synthetic data for this set of training, especially for layouts. But I do know there are certain type of work which they claim they have this like they can easily synthesize this like layouts and then to help and they produce this like train data for free. My point for this is that synthetic data would definitely be helpful if you have a great template for all the layouts you can see for this set of documents. But my personal feeling is that, or the reason why I don't want to use that is layout is such like a complicated stuff which they are man-made, right? So basically, if you just changing from different, not saying different type of documents, right? If you're just changing different type of scientific documents, for example, you say paper published in medical domain, and if you see paper published in scientific in CS domain, right? They're just completely different. So my feeling is that it's just like no such good way for us to just to enumerate all the kind of different layouts that we can have easily, such that even if you cannot do this like enumeration for the layout types, or maybe just like specify this layout types, then you cannot. And my feeling is that you cannot create like a faithful representation of this like a synthetic data, and such that if you're just using like a limited subset of like synthetic patterns for this layout structure, then it says that your model can only work good for this like specific sector of layouts, but not maybe generalizable to other scenarios.
Yeah. Great. Okay, and we have one more question from Mats. My use case is a file with mixing the languages of traditional Chinese and English. Could you have some ideas about annotation and training models for multiple languages? What's the bottleneck to affect the accuracy, annotation, or building model or post-processing?
Okay, that's a great question. And I would say that's actually like a good news for you, because layout detection, right now we're discussing layout detection, right? But fundamentally what it is, right? It is just like an image object detection task. Basically, the input is like an image, and the output is like a collection of rectangular bounding boxes on top of that image, right? So there's no language, actual language information used there. So whatever language you have, traditional Chinese, even Japanese, even other languages, it doesn't matter that much because fundamentally it's like an image input. And the other good news is that actually, mixing different languages can even boost the model's performance actually, because different languages tend to have different writing patterns and writing styles, and of course, different visual patterns for the characters, right? Such that it would be like an easy clue for the model to learn to disambiguate. And that's where this like a vision-based framework can have like a benefits for these scenarios. So I would say as long as you just label a bunch of data on top of your documents, you can get relatively faster increases of the performance compared to you use other natural language processing models if the base model is not like a multilingual by nature. Yeah.
Cool. Yeah, it's interesting. Yeah, that you may want to try to mix different languages into the model just to boost the performance. It's an interesting insight.
It's more or less depend on the task, right? Basically
right.
Saying that if you have a specific task, then that's something kind of like a it's just like some like extra hints for the models to learn some way to differentiate different objects. Yeah. Okay.
Cool.
So
right.
Let's jump back to this outputs, right? So after waiting such a long time, so we get addition for each of the pages. I would say this is still not 100% perfect, right? For example, for the case here, right? You would definitely see it's missing some text here. But of course, this give, as long as you have the bandwidth to label more data and to get like a better models, to get like a more, you can of course get a relatively more robust performances on this like cases. But yeah, so we got all this thing and we store everything into this like a PDF bibs, dictionary actually. It's a dictionary list. But then let's just try to convert them into like a pandas data frame, which all the data scientists love pandas, right? So you now you got this, right? So you have this like bib item, and then you have this like a page index, right? You got all the text there, which all sort of great, right? But if you take a closer look, there's like a one issue, which is like an ordering issue. So if you check this like a two first items for page 9, right? You can see the ordering here is completely different from here, right? So the Latrin's references here, and the other one from Christophe is even on some other parts, right? Yeah, it's even here, right? So basically the ordering is not correct, and we want to do better, right? Can we just get the ordering correct for this specific task? And that's definitely possible. So basically we LayoutParser has this like a PDF token parser, which you can directly load PDF into like a collection of like PDF tokens. And the good thing is that they have this like an index for each of the parsed PDF tokens, which can be used to ordering this like a bib item boxes. So basically, I provide another version of this script, which I just wrote above. But there's like additional command we have code here, which it will reorder this like page bib tokens based on the PDF tokens. So the logic here is that each bib region corresponds to a collection of PDF tokens, right? So you can get the first token index inside each bib item, and then you can sort this like a bib items index based on this like first index, such that you can get the correct order. And I can run the code live, but it takes just too long time. So I just like skip this part. Perhaps I will just like defer this after I finish the presentation. But here you got the new part of data, which I only showed the top 10. And you can see here for the page 9 now it's being totally correct, which a simple but tough to beat baseline, but right, that's the text here. And there's the second one is from East, and the one is correct, and the others are also correct. But of course, there's still definitely challenges, right? For example, how to merge this like of course, we know this is like a part of the bib item from the last page, right? How to merge this one with with the previous one, right? And even how to recover just like errors is just like definitely challenges we can tackle in the future. Yeah. So let's come to the end. Perhaps I can just get it running and then we can go back to check the results and I can answer the questions in the meantime.
Yeah, I think Thomas, he has a question about, is it possible to train for block reading order?
Yeah, that's a great question. And the answer is yes. So there's like a recent work on layout reader. So basically they use transformer architecture to predict the reading order of the blocks. But currently in the parser, we are still discussing the best strategy to incorporate this like structure and this set of models into the tool, such that we still want to maintain this like extensible infrastructure for this tool. So, and the answer is yes, but I mean, there have been some tools which we can use to do that. And I'm not saying that as a tool, but that's a paper which we can use to do that. But it'll be incorporated into the parser in the future. Yeah.
And do you understand correctly that the block reading order means that you want to also recognize the order of the blocks?
Yes. So let's go back here. So okay, so for this specific page, right? Yes, we got this list of blocks, right? But their ordering might not be correct. So in that list, so this maybe goes first, and then this goes to second, and this goes to third. And this is not the layout detection model's fault, because the goal for the detection model is just trying to generate a bunch of boxes, but it's not to to try to understand the ordering of these boxes, right? So I mean that, and then this goes to the separate task, which is like a layout region, or maybe layout block ordering, or maybe like a reading order estimation, which is just saying, given this collection of boxes, right, we want to predict kind of like an order, or you can just say as like a graph for this collection of boxes, saying that, okay, which goes first, and then which goes next to, after the first one. And that's like a reading order detection task. Typically, this is more or less formulated as a could be like a graph prediction, or maybe could predict like a binary precedence prediction, or even just like you can formulate as like a index prediction, right? Just like a predicting on the index of each item in the correct order list, right? And there have been some research going on for that direction, and I would say there has been some tools for this purpose, but I am not quite sure to what extent how good they perform. Yeah.
Interesting. Okay.
Cool. Do we get it? Okay, I think we got it. So yeah, and I can run this again, so you can see the exact same results here. Okay, so I can elaborate on the real detection problem a bit. So which I can show you the actual ordering of the tokens as well. So which is, so I'm also drawing this like box, right? And we also have this like big items for this page, right? So we firstly show this same realization, right? But LayoutParser has this API, which is like a show element ID. If we set it to true, and then we can reduce the font size actually to something like 8. So if we run this, you can see there's like an index for this each box on top of on the top left corner. But this probably I should make it larger because it's too tiny. So you can see there's like a numerical index on top on the left top corner of these boxes, right? This which corresponds to how they are stored inside that. And the goal for reading order estimation is just trying to make this 0, make this 1, and make this 2. Just make them like a reasonable, like the way we're reading this set of like a list of objects. Okay. Cool. Do we have more questions, or yeah.
Not yet.
Okay.
Not yet. Yeah, I think we don't have any.
Cool. Awesome. Yeah. Yeah, but I mean, to recap, so basically we have this set of functionalities, which, we can go back to the last slide, I guess. We have this like layout parser, which allows you to parse, complex documents with deep learning, basically for layout parsing, right? And Label Studio is just trying to get the data annotation, is an awesome data annotation tool, which allows us to train better models for use by providing this like a customized and easy to use labeling interfaces.
Great. Any last questions before we wrap up? Yeah, we'll be publishing so all the materials and everything that Shannon and Ben was sharing, we'll be publishing that in both Slacks. So just give us a little bit of time. Cool. Right, guys, thank you so much. I think it was really interesting for me personally, and I think for our audience. As Shannon mentioned, during the Slacks, send the questions. We'll be there to support you. Thanks, guys.
Thank
Take
you.
care.
Thank you.
Thanks so much.